Hi, I'm Tim Berglund, and this is Introducing DataStax Enterprise Graph. Graph databases aren't new to the world, but they are new to a lot of developers. So I want to take a few minutes and explain what DataStax Enterprise Graph is all about, basically what a graph database is, and a little bit about its internal architecture. Now, it is a real-time transactional OLTP graph database, and it's based on some battle-tested open source components. There's Apache Tinkerpop, that's kind of the basic graph data model, and the traversal language comes from Tinkerpop. Apache Cassandra, of course, this being DataStax Enterprise, provides the underlying storage layer. Some full-text search and indexing features can be provided by an integrated Apache Solr, and of course there's Apache Spark in there for fast analytic traversals. But DataStax Enterprise Graph is a little bit more than the sum of those four parts. Some of the other features of the product, like for example comprehensive enterprise-grade data security, are fully integrated. You've also got management and monitoring with Ops Center, and of course visualization with DataStax Enterprise Studio, which is a really cool way to interact with the graph and look at, visualize subgraphs. So with the addition of Graph to DataStax Enterprise, we have a true multi-model database. You still have the good old Cassandra tabular model, which is good for many, many transactional applications, and you've got this new data model of Graph. Let's talk just a little bit about the architecture of Graph. Now, the front end, that is what you as a developer see when you interface with this database, that looks like Apache Tinkerpop. That's a property graph. We'll talk about what that is in just a few minutes, and the Gremlin traversal language. There are also some proprietary API elements that we'll cover in detail in other parts of the course. But that programmer front end, that's really the thing that you see as a developer when you're using Graph. Now, if you go all the way down to the bottom of this diagram, the back end, that's Cassandra, that's Solr, that's Spark. Those are kind of the heavy lifting data backend of DataStax Enterprise. Now, the way in which a graph is represented in the distinctly non-graph database of Cassandra, and the way certain types of traversals are enabled by Solr and Spark, to a large degree, as a developer, you don't have to worry about that. That's the thing that's done in this diagram by what we call the middle layer. That's schema, that's the actual representation of graph data, and the way transactional and analytic queries are mapped onto that back end. What you see as a developer is basically you see Tinkerpop, you see some proprietary API elements, you know from an operational standpoint that this is being implemented in terms of these things like Cassandra and Solr and Spark, but you don't really have to think about that mapping. You really get to engage the front end, learn those front end APIs, and that middle layer does the translation for you. So what you end up getting is a scalable graph database. Now, historically, that's a very thorny problem to solve, and it's a thing that DataStax Enterprise Graph does for you. Now, let's dig into that front end a little bit and talk about Apache Tinkerpop. It is kind of a general purpose graph computing framework. It isn't a graph database itself, but it's kind of an interface and a model for how a graph database ought to be, sort of a graph database API. It provides a structure, and it provides a process for accessing graph data or traversing graph data. That structure is what we call a property graph. Now, property graphs are very intuitive, simple, expressive, flexible data models. Briefly, what are the components of a property graph? Well, you have vertices, or sometimes people call them nodes. In this diagram, those are the blue circles that say things like person, user, genre, movie, and those represent individual entities out in the world. So an actual vertex in a graph will be a real person like Johnny Depp, or the movie could be an actual film like Alice in Wonderland. It's not necessarily a type like a generalized film or an actor or something, but each vertex is a specific thing. The edges between vertices model the relationships between things. Like Johnny Depp is an actor in Alice in Wonderland. We have an edge for that. Alice in Wonderland as a movie belongs to the genre adventure. Probably belongs to other genres too, but those edges model those relationships. Now, each edge and vertex in a property graph is kind of like its own little map, its own little mini key value store. And so they have properties. Those model the attributes of entities and relationships. You can see here, for example, there is a user in the middle of the diagram there, and he is male and age 12, and those are some properties of that user, and he has the rated relationship with the Alice in Wonderland movie. He's rated Alice in Wonderland. That relationship has a property, and that's the rating of 5. So you can see some really simple things that we would do with things in the real world are very easy to model with a property graph. Now, to query a graph database, we're going to need a different language. Cassandra uses CQL, which is a lot like SQL, which is kind of everybody's default mode. That's the database query language that we expect to see. Graphs are so different from relational databases, though, that we need a different language. In this case, we use Gremlin. Gremlin is technically Turing complete. It is a functional language, but what we use it for is not general purpose programming tasks, but describing graph traversals and occasionally also describing graph mutations. Now, this is a thing that we will spend a lot of time covering together. There's a lot to learn about Gremlin, but let me just show you an example of a Gremlin query here. You can kind of read this. There's some boilerplate stuff in there that you just kind of have to trust us. We need the G.V and that sort of thing. But it really looks like we're looking for something in the graph that has the type person and the name Johnny Depp that looks like that's specifying a property. And it has an incoming edge with the actor type. And that thing, what would have an incoming edge, if you look back at the graph diagram, that would probably get us to a movie. So if you start with a person, the incoming edge of type actor, that's going to come from a movie probably. We want the movie whose year is greater than or equal to 2010. And then at that point, whatever movies are in that universe, that is whatever movies Johnny Depp has been in since 2010, we just want the title and the year. And in our sample output here, we've got 3 of them: Into the Woods, Pirates of the Caribbean on Stranger Tides, and Alice in Wonderland. So you might not be able to write Gremlin at this point, but it is a little bit readable. It's not too tough to look at. You can kind of get an idea by looking at a Gremlin query what it might do. Again, lots more to learn there, but I wanted you to have a quick look. Again, a look at the open source technologies that power parts of DataStax Enterprise Graph. Remember that middle layer, super important, does the translation from Tinkerpop to all this stuff. So you don't need to think directly about these components all the time, but you should know that you've got Apache Cassandra. You've got the best distribution of Apache Cassandra down at the bottom there. That's actually storing vertices, edges, properties. It's storing indexes. It's handling real-time querying. That's always there, storing your graph data. Some types of graph traversals can also be powered by Solr, which will do other kinds of indexing, and of course full text search, which Solr is good at. And there are some analytical types of queries that actually get translated into Apache Spark jobs. So optionally, Spark can be a part of the equation and help accelerate some types of OLAP graph traversals as well. The secret sauce that makes graph so valuable is the mapping of the abstractions of the graph database. That's the Tinkerpop API to the back end. So how do you model a graph in Cassandra? If you know Cassandra, maybe your mind is going right now and you're thinking, how would I model a graph in a Cassandra schema? Well, we've done that for you. So that mapping is done. And the translation, the storing of the vertices, the relationships, all that stuff happens for you. And then the actual execution of queries and how efficiently to do Tinkerpop graph traversals or Gremlin graph traversals against that data model, either in sort of a transactional mode, the OLTP kind of query, or analytical queries that we might even do by compiling down to Spark jobs. All that stuff gets done by the middle layer. Super valuable. It's what makes graph a useful product and not something you have to build yourself. When you need a graph database, you are sunk without one. But of course, you don't always need one. It's good to have some guidelines to know when should I be thinking graph, when should I not. Now, just a couple of thoughts for you there. If your problem domain is naturally represented as a network, a web, a graph, something like that, if it lends itself to that, if when you're diagramming your domain and debating it and thinking about it and trying to explain it to people, if you go to a whiteboard and you find yourself drawing edges and vertices, that's a sign that you may need a graph database. Also, if you find that the problem focus is on discovering connections and links and relationships, when you do sort of old school relational data modeling or newer Cassandra data modeling, you do think about the relationships. In Cassandra data modeling, we actually create tables to reify relationships that we describe in our data model. So we build in those relationships into the data model. And that's also true of, as I said, older school relational data modeling. That's a thing that you design. When you're trying to discover relationships and links and dependencies, when you don't always know how to get from A to B or what the meaningful connection from A to B is, and when you're describing your problem and trying to solve things, when you find yourself focusing on that sort of thing, that's another sign that you probably need a graph database. That, of course, is bottom-up reasoning. When you're thinking as a developer trying to solve problems, you kind of have these smells in your design discussions that suggest maybe you need a graph. From the top down, we can also think of kinds of applications that lend themselves to graphs. Now, Internet of Things is often a classical time series problem. That is not a graph problem, but there are interesting networks that can pop up in large-scale IoT deployments where you need to model them with a graph and a scalable graph. The broad category of customer experience applications. This is a thing that people are building. It's a very hot topic right now. Sometimes you'll hear it talked about under the heading of digital transformation. But really, this is a set of applications that try to give businesses a comprehensive view of what a customer is doing. And sometimes we call that Customer 360. Or if you're trying to build some kind of a tool or platform that gives your customers a single view into every way they can interact with your business. Often that kind of application surfaces problems that are fundamentally graph problems. There are other things like personalization, recommendation engine, fraud detection, classical graph problems, but this exciting new customer experience category is a thing more and more companies are getting into, and you may find as a developer, as an architect, that is on your menu in the future. It's likely to be, and you probably want to be thinking about graph as you engage those new opportunities.